Hello, and welcome to Synoptic Question 20 mark, looking at the ways that we can link the two areas together. So we look at the final screencast now, looking at how we could link potentially energy systems to start with to aerobic capacity, and then we'll have a look at then we'll have a look at recovery and how that might link to ergogenic aid. So that's going to be our focus now then. So if we start off, this is in your packs, really important that you kind of get an understanding of this. So I think with regard to energy systems, we've already had a look at the aerobic system linked to aerobic adaptations. So what I'd ask you to look at this one then is just to make sure you have an understanding of the energy continuum. So for the energy continuum then, in a nice world, you get this, okay? So you'd have an understanding of the kind of ATP-PC system coming down here. So you've got that bit, you've got glycolytic coming over here, then you've got the aerobic system. And all of those are dictated by the intensity and duration of exercise. If it's high intensity, low duration, it's going to be the ATP-PC system. If it's kind of high to moderate intensity, but then a kind of moderate to low duration, which you're looking at 3 minutes there, it's going to be the glycolytic system. And finally, you've got your aerobic system for those low to moderate intensity but high duration activities like so. Now, obviously, the interchange between them, there are certain factors you could get a question like that, but what I want you to have a look at is kind of, if they don't give you this, they might actually give you like a contribution table like this. Now, I showed you this in lesson, you've had a go at this, but it's worth just having a look over it, I suppose, just to make sure you feel okay with it. Remember, if you're talking about these systems, remember this one will be the ATP-PC rather than alactic, it won't confuse, that would be the glycolytic. But when you're looking at these, you're kind of thinking, right, you have to say, whenever you're talking about this, 100 meters, 9.8 seconds, the main system is the ATP-PC system, and we need to then remember, when you're saying, first of all, the energy continuum is a relative contribution of the energy systems dependent upon intensity and duration. You start off by that. You need to then talk about the process. If it's a high intensity, it's more likely to be the ATP-PC, blah, blah, blah. You know the start bits. You know the start bits about energy systems. Then you've got to interpret the data. And when you're talking about the system that is predominant, it asks you to examine the information, explain the changes. So you have to talk about the fact that if it is this, you've got to talk about the advantages of the system that's predominant. Okay, and then do you remember on this one we're saying, right, so when you got down to this one, you would have probably expected a higher contribution from the glycolytic system because it lasts in that kind of period between 10 seconds to 3 minutes. However, do you remember saying that the reason why there was a lower percentage of glycolytic or lactic acid system was because of those harmful effects of lactic acid? Okay, and you had to look at that section. And then when you get down to here, obviously when it's an obvious predominant, you talk about the fatty BC, the advantages of those sections there. So what I'm asking you to do is, when things make sense, talk about the advantages of the system that is predominant. In this case, the middle one, if this is the situation, you must talk about why this one is not predominant when you'd expect it to be. Okay, complex reactions, the stuff we talked about before. And then finally, you've got down this one, which is looking at the kind of the easy fatty BC, advantages of the aerobic system, fats as a fuel. No waste products, aerobic, got time to break down the fats, all these things. So what I'm going to do is that's part one. You would have to interpret that. What's the energy continuum? I'll show you the mark scheme section in a minute, but just be aware of this. If you do have to do this, have a look through your notes. I'll put on the mark scheme in a second. This bit is really important because this will be your part two. Explain why the percentage contribution of each energy system will probably change for a recreational runner performing in the same distances. And you have to then start to talk about the adaptations that would have taken place as a result of training. Okay, so you could maybe link in a few anaerobic adaptations, your strengths, but mainly aerobic things for this. So let's have a look then what you'd be looking for in a mark scheme. So for this, then, changes in energy systems, energy continuum should define that. Talk about the kind of distance and intensity stuff here. 100 meters. You can see there, as the intensity is high, needed quickly, no oxygen required. The aerobic bit, it's anaerobic, so no oxygen required. Few reactions take place in the muscle cytoplasm. Then, this one, 800 meters, relies less on the anaerobic PC, lactic acid system, more on the aerobic system. There's limited PC stores, glycogen could run out, over-reliance on lactic acid would cause. Remember all those things we talked about here, really important you don't forget that. So lactic acid, remember, increases acidity in the blood. decreases blood pH. On top of that, that will then denature enzymes. That will kind of cause problems. So make sure you talk about that. And also you've got your energy yield here. It only produces 2 ATP, so it'll be inefficient for that. It's really important you see that figure and look, because you would expect the lactic acid system or glycolytic system to be the predominant one, but it's not, because it only has a 2 ATP yield. Lactic acid can lead to these kind of detrimental kind of things happening to our body that I just explained then. So that's really important. Obviously, PC, the ATP PC is very minimally used because of the fact that PC stores run out in 10 seconds. So this bit then, 5,000 meters, you can see on this, more. So why is the aerobic system 93% predominant? Well, it's 93% predominant because it requires high duration activities with low to moderate intensity. It leads the breakdown of glycogen and fats. Okay, it has the highest energy yield, 34 to 36 or 38 overall, obviously ATP, and then anaerobic systems, you might say, only come in very at the start, to sprint start, sprint finish. And that's your kind of sections for that, so how you look at it. Now, obviously, when you're talking about the adaptations, this is quite a good way to look at it. This is linked to aerobic adaptations, but you're talking about how the recreational runner would not have them, because they wouldn't be as fit, so they'd have a lower VO2 max aerobic capacity, because they've got smaller PC stores, because they've got they reach OBLA earlier, because they've got less myoglobin, because they've got less mitochondria, because they've got less aerobic enzymes, okay, because they've got a lower cardiac output, because of a smaller heart size, because they've got lower red blood cells. And you can see how this is basically all the adaptations, but just giving it a negative slant, because everything an aerobic adaptation or an aerobic athlete or a trained athlete would have, a non-trained athlete would not have. Okay, so that is really important. Your aerobic adaptation, yet again, become the second part of a Synoptic 20-mark question. So if I went off from there then, hopefully you've seen that, see how that could work. Look back if you need to, pause the screencast on the mark scheme you feel that would help you. But again, that just shows you, we'll just go back quickly here, how on here you're looking, on here you're looking at how energy systems go straight through to the aerobic capacity or the aerobic adaptations. So that could be energy continuum linked to those. Let's have a quick look then onto recovery. Okay, so recovery, remember epoch, the process by which we recover can be split into 3 parts on the spec. You're talking about the fast recovery, you're talking about the slow recovery, both of those are components of epoch, and finally you have those implications for planning future training sessions due to your knowledge of epoch or recovery. Now that in itself, they're 3 areas. So obviously you could have to talk about the fast component, you could have to talk about the slow component. What is massively important if you think about it is that some of the key things, implications for training sessions that you're going to plan as a result of recovery linked to aerobic training type. So for example, interval training, HIIT training, changing the kind of work-rest ratios. But really importantly, if you're trying to enhance recovery, we're trying to do 2 things, aren't we? We're using excess oxygen to try and resynthesize PC in the fast component, and then also to kind of remove lactic acid. So you start to think now, can you start to think about any of these kind of ergogenic aids that could aid our recovery? So if we go down from here then, let's have a look. So recovery in terms of the graph, okay, so you remember this is oxygen consumption and you've got your recovery period here. So as you're going across here, you start to think, you rest, exercise in terms of oxygen consumption, you here, remember there's the oxygen deficit, not as important. What is massively important is here. When you finish exercise, your recovery period is split into 2. The fast component, okay, which you might well also call a alactacid recovery system, and then the slow component, the lactacid recovery system. Now remember, there's a time periods, we're looking for these. You could get a nice easy question that says, explain the process of recovery in points A and D. Okay, that could be really, really kind of beneficial. It could ask you to explain things that could enhance recovery. So the easiest question could be just looking at that and saying, right, explain the process of epoch, fast and slow recovery, and you go down your what, how, O ratio, what, how, O ratio, and then elevate O. Remember those key things there. However, that's easy. And if you did get that, you know, obviously you'd feel pretty good, I'd imagine, in talking about the process of recovery. When it becomes more difficult is here. So I've shown you this as well. You've done a homework on this. So when it comes in, and basically what this one is doing is not asking you to directly talk about lactic acid, fast and slow recovery. It's asking you to look at this component, saying, right, by judging this, so physiological measurements of a hockey player 5 minutes after a game. So you know now one system will have worked, so all the things you'd expect to be back, PC for example, is back, okay, because the fast component recovers PC stores in 2 to 3 minutes, and then you've got other things here that are not quite so kind of easy to understand. So you've got to analyze the physiological measurements shown on the graph. Okay, so remember, heart rate still high, respiration rate or ventilation rate as you put it in our specification now, and then on top of that you could have your metabolic rate being high as well, or temperature, and you think there, right, so from here you start to think these are the things that are located, we're talking about in our second recovery system. Can we remember what they do, why they're still high? Can we see why this isn't fully high yet? Why hasn't that been done? Because how long does this system take? And you can start to see what you have to do is make sure you segregate your answer into subheads and start to talk about what you see and why you see it linked to recovery systems. So what I've done here, I've used an outstanding example of this. It was uploaded onto Padlet. So I'll let you have a look through this now. Pause the page where you need to for the analysis. But before I do that, let me just say this. The second part could well be evaluate the use of ergogenic aids that could aid recovery. Okay, so again, ergogenic aids are massive links for these 20-mark questions. Let's have a look then. So PC. So fully recovered. Why? Because it uses the fast component of recovery, lactic acid recovery. PC stores, so 5 minutes after the game and only takes 2 to 3. There's some extra information that you could talk about with regard to the process of this PC recovery taking place. Down here, lactic acid then is still high. Okay, because they haven't had a full time to break down lactic acid via oxidation, which is the process of the slow recovery. Now, you can kind of look down here, anything in red is going to link to any of our stuff that we've done in recovery systems. If you want to just check onto here, these are just additional bits on there just to make sure you get the kind of highest grade. Then, once you've done the lactic acid levels, you don't need all of this, but this is just some information for those who want to revise this, just in case. On top of that, glycogen, if you want to have a read through, so glycogen is low. Okay, because glycogen is an energy fuel, so lots of it is used during the activity. So lots of that glycogen has been depleted. Now, the problem is it takes a while to get this glycogen back, same with myoglobin, etc. So that's what it's there at the moment. But it isn't fully low because if you go back to here, okay, so your glycogen isn't completely depleted because they might have had a glucose-based drink at the end of it just to kind of aid their recovery. Heart rate and respiration or ventilation are really important. So see, this is still high, it's still elevated. That's the most important thing for heart rate. And why is it so important that heart rate's elevated after exercise? Okay, because it means that we have an increased blood flow, stroke volume, cardiac output, and this will help removal of carbon dioxide and lactic acid. Okay, so this process, obviously, any oxygen that we have as a result of this kind of cardiac output to our American muscles will help get rid of lactic acid as we build through it. Now, the other thing you might start to say, why have they still got a moderately high heart rate? This could be due to an active cool down they might have been doing, if you want to add that section there. Respiration rate, same with this bit here. The respiration rate is also elevated because of an increase in breathing rate. So at the end of it, your breathing rate remains elevated. So this is key because when we finish, in order to, for our recovery systems, both fast and slow, we need between 3 and 5 for our first one, and then 5 to 8 for our second one, which allows us to remove this lactic acid. That is why they're still high, because you want it, and that could be again due to a active recovery or cool down. So hopefully you can see how they work. Now, obviously, on top of that, ergogenic aids could be used, and remember the process of recovery can be aided by anything really that helps us get oxygen back to our muscles. So you could talk about here, so EPO. If you've got more red blood cells, it means you're carrying more oxygen to your working muscles. So that's good for it, but it's also good for after, because you're getting oxygen delivered quicker to your muscles. Again, blood doping could help your recovery. It would certainly quicken your recovery. Intermittent hypoxic training, okay, after you've done that hypoxic, it will help your recovery. Again, these have been used all the way through. I'm just going to go now, obviously glycogen loading. The more you have glycogen you have in your muscle, that will mean the more that you less it's going to be depleted during the exercise, so recovery recovery will be an easier process. Hydration, follow and exercise, really important. We have those hypertonic sports drinks. These are really important now. Nitrates, beetroot, blood flow, increased blood flow to the working muscles. This can help you in that situation. Bicarbonate, there's a buffering of lactic acid, so it helps remove the lactic acid or utilize the lactic acid in recovery. Cooling aids, absolutely